This video is about IMFA, or intermolecular forces of attraction. So IMFA is an interaction that doesn't form an actual covalent bond or ionic bond. This is less strong, okay? Weaker types of interaction. They only exist, okay, as interactions that can be separated easily. Okay? They can be separated using physical processes. Okay? Yung mga processes na hindi nagre-require ng changes dun sa identities ng molecule. Okay? So, number one, this first type involves the polarizability of atoms or molecules. Okay? So, as your polarizability increases, okay, yung electron cloud ng iyong molecule or atom mas madali siyang di-distort ng external electric field or external charge. Okay? So that's polarizability. And we already discussed that the trend in polarizability down the group, so punta tayo dun sa ating periodic table. So down the group, okay? Down the group, the Z effective decreases. Okay? So kung nagdi-decrease ang Z effective, nag-i-increase ang polarizability. Okay? So, how about from left to right? So, from left to right, okay, nag-i-increase ang Z effective. So, therefore, yung polarizability mo, bumababa. Okay? So, ibig sabihin, yung mga atoms or yung mga molecules na may mga ganitong atom sa side na to, they have low polarizability. While yung mga molecules naman na may ganitong atom, okay, yung mga nasa baba or mga nandito, they have high polarizability. So, if you look at the halides, okay, for example, this group, okay, so meron tayong mga corresponding diatomic molecules. So, meron tayong F2, Cl2, Br2, and I2. Okay? So, mapapansin nyo dun sa mga diatomic molecules na yan, pagka papunta ka sa iodine or if you go down the group, okay, nagiging solid siya. Kasi ang F2 ay gas, chlorine is gas, bromine is liquid, and I2 is a volatile solid. So, nag-i-increase yung intermolecular forces of attraction as you go down the group. Fluorine, okay, is a very light gas. Chlorine is a gas na, light pa rin siya. Bromine is already a liquid. So, ibig sabihin, hindi yan masyadong nagmamatter sa mass niya, kundi dun sa interaction ng mga bromine. Because bromine is still a volatile liquid. Okay? And iodine is still a volatile gas. So, volatile siya. Volatile solid pala si iodine, sorry. So, volatile siya, pero nagpo-form siya ng solid. Okay? The interaction is strong, but the interaction is temporary. Okay? So, ayun yung parang hindi naman siya mystery, but this is a trend that we observe dun sa mga diatomic halides. So, that is due, okay, to the intermolecular force of attraction, number 1. Okay? Number 2, interactions between permanent dipole. So, this is prominent. Okay, pagdating natin sa water, okay, water has a permanent dipole due to its geometry. Okay? So, yung interaction between water molecules, they are very strong. And also, there are interactions between ions and dipoles. Kaya nagkakaroon ng ion-dipole interaction, nagkakaroon tayo ng mixing sa solution because of this particular interaction. Okay? So, physical parameters that are in direct consequence of IMFA, so physical state, if you have higher IMFA, you are more condensed. So, meron tayong gases. So, gases are the least condensed. So, ibig sabihin, hindi mataas ang IMFA nila or their IMFA is practically non-existent. Kaya sila gas. Liquids have a moderately strong IMFA. Okay? The IMFA strength is enough to form a condensed phase pero not very enough for them to assume their own shape. Not like the solids. Okay? Number 2, melting and boiling point. So, pag tumataas ang melting and boiling point, ibig sabihin mas madaming energy ang kailangan mo para magkaroon ka ng conversion from solid to liquid to gas. So, to be able to convert something into a less condensed phase, kailangan meron kang energy input para matanggal mo or para masuppress mo yung IMFA na yun. So, pag kailangan mo ng mas mataas na energy, ibig sabihin, mataas yung IMFA nila to begin with. Okay? 3, vapor pressure. So, vapor pressure is the pressure exerted by the liquid or the solid, okay, through emission of gas particles. So, nagkakaroon ka lang naman ng emission ng gas particles kung nag-e-escape siya sa iyong phase. So, kapag mas maraming nag-e-escape, mas mataas yung pressure kasi mas maraming gas yung napoproduce dun sa phase mo. Okay? So, ibig sabihin, if you have high IMFA, dapat mababa lang ang vapor pressure. Okay? Kasi, yun nga, kapag mataas ang vapor pressure, maraming nag-e-escape na gas. Okay? Tendency to mix with other compounds. So, mixing is actually an IMFA-dependent process. Kasi, you may not mix because of your incompatibility sa IMFA. Okay? Kasi sa mixing, meron tayong tinatawag na solute and solvent. Okay? So, lagyan natin SV, solvent, and this is SO. Okay? So, yung solute-solvent interaction, dapat greater siya sa solute-solute, solute-solute, and solvent-solvent. So, dapat yung solute-solvent interaction, mas mataas siya dyan sa dalawang yan. Kasi kung hindi, ibig sabihin, hindi sila maghahalo kasi mas mataas yung interaction ng solutes sa isa't isa or yung solvent sa isa't isa. So, why mix, di ba? So, yun yung concept ng IMFA in terms of the mixing of the solute and the solvent. Osmotic pressure. So, osmotic pressure is not like vapor pressure. So, osmotic pressure is like parang transfer of solvent from one phase to another or from one system to another through a semi-permeable membrane. So, kaya tumataas yung osmotic pressure dahil dun sa ine-exert ng solvent dun sa semi-permeable membrane. So, mas gusto niyang pumasok dun sa kabilang system. So, dapat mataas ang IMFA mo para mangyari yun. Okay? So, IMFA is greater if the osmotic pressure is observed to be greater. So, yun yung parang idea dito. Okay? So, the first IMFA I'll discuss is the London dispersion force. So, London dispersion force is a force of attraction due to temporary dipoles. So, temporary dipoles are formed from the polarizing or polarization of molecules. So, again, saan nakadepende ang polarization? Sa size and sa Z effective. So, the lower the Z effective, the higher the polarization or the polarizability. If the molecule is large, mataas din ang polarizability. Okay? So, ang nangyayari lang naman dito, nagkakaroon sila ng repulsion muna ng kanilang mga electron cloud. So, yung isa sa kanila, magkakaroon or actually both of them will polarize. Okay? So, from randomly scattered electron clouds, magkakaroon ng parang positioning or nagkakaroon ng polarization yung electron clouds. So, mapupunta dito yung electron cloud ng isa, tapos ma-attract dun sa positive center yung electron cloud ng kabila. So, yan yung temporary polarization. Nawawala yan kapag naghiwalay na ulit yung molecules or atoms. Okay? So, tingnan natin dito sa representation sa baba. So, nung una, random lang din ang scattering ng electrons dito. And as atom A approaches atom B, nagkakaroon ng polarization. Okay, kung na-polarize si B, mapopolarize din si A kasi marerepel ng negative charge yung electron cloud. So, mapupunta siya sa kabila. So, ang mangyayari, ganyan na. Ito na yung kanyang negative charge density. Ito na yung positive charge density. So, mag-a-attract yung dalawa, but this is again temporary. Kapag naglayo na yung dalawang atom, babalik na siya dun sa random or randomly distributed or evenly distributed na electron cloud. Okay? So, polarizability is involved. Okay? As the polarizability of the molecule increases, the London dispersion force increases. So, ano yung mga yon? Ano yung mga factors? Molar mass. So, higher molar mass, okay, higher LDF. Okay? So, syempre, since molecules yung pinag-uusapan natin, hindi lang sa molar mass nakadepende. What if the molar mass is the same? So, nakadepende na yun sa shape ng molecule. So, kapag LDF kasi, kapag London dispersion force, dapat maximize yung surface area of interaction para magkaroon ka ng maximum polarization. Hindi pwede na parang hindi involved yung ibang atom ng molecule mo sa polarization. Kasi kung ganun ang mangyayari, hindi effective yung LDF. Mahina siya. Okay? So, surface area is also a factor. So, higher surface area, higher LDF, given the same molar mass. Siyempre, mas mataas pa din yung may mas mataas na molar mass. Pero, dapat kino-consider din natin si surface area. Okay? So, tulad nito, methane has only one carbon, CH4. Okay? CH4. This is C2H6. Okay? This is C3H8. This is C4H10. So, palaki ng palaki yung iyong molecule, pataas din ng pataas yung boiling point. However, itong molecule na to, this is a C5H12. This is also C5H12. Pareho sila ng molecular formula, pero mas linear si C5H12 dito or si N-pentane kaysa kay dimethylpropane. Okay, so dimethylpropane is a more branched molecule. So, hindi ganun kataas ang surface area niya. Okay? So, ibig sabihin, mas mataas ang LDF ng N-pentane kaysa sa dimethylpropane. Okay. So, that's LDF. Again, molar mass. Okay? Sa LDF, molar mass and surface area. And also yung polarizability. Polarizing power or polarizability of your atoms. Okay? So, for hydrocarbons, again, since non-polar ang mga CH bond, so all hydrocarbons are effectively experiencing not dipole-dipole interaction, but London dispersion force. Despite the fact na carbon and hydrogen to, polar siya per se, pero not strong enough to be considered polar on the Pauling scale of electronegativity. So, na-compute na natin to. In, change in electronegativity or in difference nila is 0.4 only. So, CH bond is borderline non-polar. Okay? Yan. So, ang mangyayari ngayon, or i-consider na natin ngayon sa organic chemistry na all CH or hydrocarbons are non-polar. Okay. So, yun na yung ating convention, kumbaga, or yun na yung ating observation sa hydrocarbons. So, ngayon, yung mga hydrocarbons, there are three types. So, alkanes. Alkanes contain carbons that are all sp3. All sp3 carbon. So, sp3 kasi wala kang makikitang double bond doon or triple bond. So, again, this is yung CsP3. Okay? And CsP3, which is a sigma bond. Okay? Ayusin natin. This is a sigma sp3. This one, okay, is a sigma bond between an 1s and the carbons sp3. Okay? So, yan lang naman yung dalawang bonds sa mga alkanes. Yung sigma sp3 and 1s ng hydrogen and the carbon-carbon sp3 sigma bond. Okay? So, punta na tayo sa alkenes. So, sa alkenes, the carbons here are sp2 hybridized. Okay? So, makikita natin yung mga sp2 ng carbon na to. Yan yung tatlong sp2 orbitals niya. So, it usually forms a trigonal planar with respect to each carbon. So, itong carbon na to ay C, C, H, H. Okay? Ganyan ang itsura niya. This is an ethene. So, ethene is flat because of the trigonal planar geometry of both sp2 carbons. So, ano-ano yung mga bonds na involved dyan? So, meron tayong sigma bond ng dalawang CsP2, CsP2. So, yun yung banda rito. Okay? This is the one. So, ayusin ko muna. So, this is, okay. Yun yung sigma sp2, sp2. Next is yung sigma ng CsP2 and the hydrogen 1s. Okay? So, ito naman yun. Okay, that's the sigma bonds. So, nakita na natin yung sigma bonds. Ngayon, let's look at the pi bond. Ito yung pi bond. Okay. Yan yung dalawang pi bond na to. So, that's pi. Okay. C of 2p, C 2p. So, yun yung mga 2p orbitals ng dalawang carbon na yan. So, that's how they form or how they bond through a pi bond. Okay. Finally, we have the alkynes. So, yung alkyne ay triple bond carbon. Magkakaroon ka ng at least one triple bond. So, meron tayong sigma CsP, CsP. Okay, this is the one right here. Okay, and then we have sigma of the sp hybridized carbon and the 1s orbital of the hydrogen, which is here. Okay, kita nyo. And finally, we have pi bonds. Okay, so pi bond number 1 is C2p, C2p, which is right here, yung itong nandito. While another pi bond, okay, C2p, C2p is the bond right here. Itong dalawang to. So, i-color code ko lang para makita natin. So, lagyan ko ng blue. So, pi para makita natin. C 2p, C2p. That's the one in blue. And the one in yellow is the pi C2p, C2p. Okay? The rest are yung mga sigma bonds. Okay? So, that's for alkynes. So, next, we have this dipolar interaction. So, dipolar interactions or dipole-dipole interactions are interactions between the permanent dipoles. So, requirement dito na marunong tayong magsulat ng Lewis structures. Okay? So, sa Lewis structures kasi natin malalaman kung ano yung dipole moment ng isang molecule. So, how do we do this? Okay? So, for example, we have NH3. So, alam naman natin na ang Lewis structure ng NH3 ay trigonal pyramidal. Okay? So, kung trigonal pyramidal ang iyong geometry, yung mga dipole moments or dipole bonds are represented by this. Okay? So, the dipoles, okay, point from the region of low electronegativity to the region of high electronegativity. Ganyan ang representation ng dipole. So, dito, wala naman tayong dipole. Okay? So, i-add natin to through vector addition, yung lahat ng dipole na yan. Malalaman nyo na ang ammonia ay may ganyang net dipole moment. So, ibig sabihin, ammonia is polar. Okay? NH3 is polar. So, another example is H2O. So, H2O is a bent molecule kasi this is an AX2E2. Diba? NH3 is an AX3E. So, AX2E2, si water. Okay? Again, sulat natin yung mga dipoles. Ganyan. And the dipole moment becomes right here. So, kapag vector addition yan, ganyan yung mangyayari. Dipole moment. So, H2O is polar. Okay? Last example. So, meron tayong CO2 naman. CO2 has this particular Lewis structure. So, kayo na bahalang mag-build or mag-confirm ng Lewis structure na to. Okay? Carbon-oxygen bond is polar. So, meron tayong dipole moment na pag ganito. Okay? So, yung oxygen mas electronegative kay carbon. So, therefore, we have this particular dipole. And meron din tayo sa kabila. However, pag inad mo yung dipole na to at yung dipole na to, zero. Okay? So, no dipole moment. Or no net dipole moment. So, therefore, CO2 is non-polar. So, it's not enough that you have dipole moments. Dapat, to be able to be considered a polar molecule, you have a net dipole moment. Okay? These are net dipole moments. Okay? So, again, all molecules or not all molecules with dipole moments are polar. Okay? While, okay, all polar molecules have a net dipole moment. Yan yung ibig sabihin ng polar molecule. So, carbon dioxide is a molecule with a polar or with net or without a net dipole moment, pero meron siyang mga dipole moments. Okay? So, hindi siya polar. Okay? Wala siyang net dipole moment. So, that's how you distinguish between a polar and a non-polar molecule. Okay? So, skip natin to. So, ngayon, meron na tayong parang basis ng parang measurement ng mga polarity. It's actually through their physical properties. So, malalaman natin kapag mataas ang boiling point, for example, mataas ang IMFA niya. Because boiling point is a property of not just an atom or a molecule, but a set of molecules. Okay? So, kapag mataas ang kanilang force of interaction, mas mahirap silang i-boil. Okay? So, let's look at this table. So, pansin nyo, this set of molecules are from the same group. Carbon, silicon, germanium, and tin. Okay? So, nag-i-increase regularly yung kanilang boiling point kasi pabigat ng pabigat yung atom. So, the regular increase is explained by the increase in the molar mass. So, nangyayari lang dito ay more of LDF. Okay? Kasi kung sa molar mass lang nakadepende ang iyong increase in the boiling point, ang nag-i-increase lang sa'yo ay LDF. Okay? So, hindi masyadong nag-i-increase yung ibang factors. Like, you can say na meron tayong tinatawag na dipole-dipole interaction for some molecules. Pero, hindi yon malaking factor. Okay? Now, let's go to the ammonia or the amine group or the nitrogen group pala. The chalcogen or the pnictogens pala. Okay? So, these pnictogens have anomaly. Tingnan nyo yung nitrogen. Ang taas ng kanyang boiling point compared sa phosphorus, sulfur, and antimony trihydrides. So, Weird. Okay? So, ibig sabihin, hindi yan explained by LDF. The dipole moment of NH3 is very large compared to the dipole moments or the net dipole moments of phosphorus, sulfur, and antimony trihydrides. Okay? Sobrang taas ng dipole moment niya compared sa mga ibang molecule sa baba ng group. Pero the anomaly is too big. Okay? So, ibig sabihin, meron tayong insanely strong na polar interaction or dipolar interaction. The same goes with the chalcogens. Okay? So, you can see this is water. And it boils at 100 degrees Celsius. Okay? This is hydrogen disulfide or hydrogen sulfide. It boils at negative 60 kahit mas mabigat siya sa water. Okay? So, ibig sabihin yung dipole moment ng water, mas mataas dipole moment ng hydrogen sulfide. Mas mataas din sa selenium dihydride and tellurium dihydride. So, may anomaly. Okay? And the anomaly is up to fluorine. So, these are halogens. So, the hydrogen fluoride gas nasa boiling point of 20. Okay? Hydrogen fluoride siya pag pure. Hydrofluoric acid siya kapag in solution or in aqueous solution. So, the boiling point of hydrogen fluoride is too high compared to hydrogen chloride or hydrochloric acid in solution, HBr and HI. Okay? So, the anomaly can be explained by the so-called hydrogen bonding. Okay? H bonding. So, H bonding is a dipole-dipole interaction. Pero this particular dipole-dipole interaction is very strong compared to the normal dipole-dipole interactions. Because hydrogen is a very electropositive atom. So, kapag nilagay mo yung isang very electropositive atom sa isang very electronegative halogen, medyo natural na magkakaroon tayo ng mataas na electronegativity difference. Okay? So, this is actually a strong interaction that can be compared to an actual covalent bond. Kaya tinatawag na bonding. Okay? Hydrogen bonding. But this hydrogen bonding is actually still breakable through physical processes. Okay? You can still boil water out to form a water vapor. Pero you cannot remove the hydrogen from the oxygen of water that using the same methods. Okay? You need chemical reactions. So, yun yung pinagkaiba ng hydrogen bonding as an IMFA dun sa actual oxygen-hydrogen bond na covalent. Okay? So, the hydrogen bonding has geometry too. Okay? Ganyan yung mga geometry niya. So, the sense of this geometry is that the electropositive hydrogen is always attracted or bonds to the electronegative nitrogen, okay, or oxygen or fluorine. Hydrogen bonding is so much weaker in lower or heavier halides or some other molecules. So, talagang ano lang siya, very evident lang siya sa nitrogen, oxygen, and fluorines. Okay? So, that's hydrogen bonding. So, ano mga features ng hydrogen bonding? So, meron tayong tinatawag na H-bond donor and H-bond acceptor. Okay? So, ano-ano yung mga H-bond donor and H-bond acceptor na yun? So, for example, you have water molecule. Okay? So, how do water molecules form hydrogen bonding? So, i-ano muna natin. Bigyan muna natin ng terms. This hydrogen connected to the oxygen is the H bond donor. Okay? While each lone pair is an H bond acceptor. So, ibig sabihin, yung water molecules or each water molecule has two H bond donors. Okay? And two H bond acceptors. Yan yung property ng isang water molecule. So, pwede siyang mag-form ng a total of 4 H bonds. Okay? Kasi meron siyang dalawang donor, meron siyang dalawang acceptor. How about yung ammonia? Okay? Ang ammonia, meron siyang 3 H bond donors and meron siyang 1 H bond acceptor. So, meron din siyang 4 H bonds. However, nitrogen is less electronegative than oxygen, kaya mas mataas ang boiling point ng water kaysa sa ammonia in pure solution. Okay? There are molecules na walang OH, walang NH, walang NH, wala ring FH bonds, wala sila niyan, pero they can still undergo hydrogen bonding. So, ano yung example nun? Formaldehyde. So, formaldehyde has no H bond donor kasi walang H na nakakabit, 'di ba? Walang H na nakakabit directly sa oxygen nila. Okay? Pero yung oxygen itself, meron siyang dalawang lone pair. So, there are 2 H bond acceptors. However, formaldehyde cannot undergo H bonding by itself. Okay? Hindi nag-hydrogen bond ang H na to sa oxygen na yan. Hindi yan nag-H bond dyan. Okay? Hindi pwede yon. Hindi yon strong interaction. So, H bonding can only occur, okay, kapag yung H or yung H bond donor mo ay nakakabit sa actual na oxygen, nitrogen, or fluorine. So, this is an H bond. Okay? That's why, in the practical sense, yung formaldehyde, bumababa yung vapor pressure niya or tumataas yung boiling point niya kapag nilalagyan mo ng tubig. Okay? So, same goes with acetone. Acetone is actually an analog, okay, of formaldehyde. So, acetone, that's yung panglinis ng kuko, di ba? Hindi naman siya nilalagay na puro o hindi siya ginagamit usually na puro kasi mabilis siya mag-evaporate. So, for it to evaporate less or para matipid tayo sa paggamit ng ating acetone, lalagyan natin siya ng water. Because water provides the hydrogen donor. Kasi, again, acetone cannot undergo hydrogen bonding in its pure state. Acetone cannot H-bond to its own acetone. Kasi walang H-bond donor ang acetone. Water can H-bond to acetone. Kasi ang water, meron siyang H-bond donor. Okay? So, yun yung requirement para makapag-H-bond ka in the pure state. You have to have both donor and acceptor para makapag-H-bond in the pure state. Okay? Kung wala kang donor, hindi ka nakakapag-hydrogen bonding in your pure state. Okay? That's what happens here. So, the example here is acetic acid. So, acetic acid, okay, can H-bond to itself. Kasi meron siyang donor. This is the donor. Actually, gray color. And this is the acceptor. So, that's acetic acid. Pwede rin siyang magkaroon ng dimer. Ang ibig sabihin ng dimer, yung dalawang acetic acid, okay, ay nagpo-form ng bond. Nagiging, dalawang acetic acid molecule sa isang entity. Okay? So, ito yung sinasabi ko kanina, yung acetone, it's a ketone, pwede siyang mag-H-bond sa water, but not in itself. Okay? Kasi, kapag in the pure state, walang H-bond donor, so dipole-dipole lang yung interaction. So, that's for hydrogen bonding. Okay, again, ito yung hydrogen bonding sa ammonia and water. So, ammonia has its own acceptor, water has a donor. So, that's the donor-acceptor interaction. So, for hydrogen bonding, makikita natin na if you have a more hydrogen bonding sites. So, ano ibig sabihin ng site? Yun yung both donor and acceptor. So, bibilangin nyo, ilan ba ang donor, ilan ang acceptor. Kapag mas maraming sites, mas mataas yung IMFA niya or mas mataas ang H-bonding niya. So, this can be exemplified by the following. So, pansin nyo, these are alcohols. Okay? Tingnan nyo to. Methanol, meron siyang dalawang acceptor, isang donor. So, 3 ang hydrogen bonding sites niya. Ganun din dito sa ethanol. Dalawang acceptor, isang donor. So, 3. Ito rin, 3, 3. Diba? Ganyan. However, sa mga ketones, makikita nyo, 2 lang ang mga hydrogen bonding sites niya. And puro pa sila acceptor. So, walang donor. So, hindi sila nag-hydrogen bond in their pure state. Kaya pansin nyo, mas mababa generally yung kanilang mga boiling points. Okay? So, dito naman sa ammonia, primary amine ang tawag dito. This is methylamine. So, ang methylamine merong isang H-bond acceptor at may dalawa siyang donor. So, 3 yan. Ito rin, 3, 3, 3. Kasi, isang acceptor, dalawang donor. So, 3 hydrogen bonding sites. How about this? Okay? So, kung secondary amine ka na, isa na lang yung nakakabit na hydrogen dun sa nitrogen. So, isang donor, isang acceptor na lang siya. Tigda dalawa na lang siya. So, pansinin nyo yung boiling point. So, dito sa una, isa lang yung carbon. So, compare natin mula dito, okay? Compare natin yung boiling point ng ethylamine tsaka dimethylamine. So, tig-dalawa yung carbon niya, dalawa rin yung carbon dito. So, ang ethylamine, 16.6 ang boiling point, 7 lang si dimethylamine. Si propanolamine, 3 rin ang carbon. Si ethyl and methylamine, 3 rin ang carbon. Pero, 47.8 siya, 36.7 lang si N-ethyl and methylamine. Even though they have the same number of carbons and hydrogens, ha. Isomers lang to, pero mas mababa yung hydrogen bonding sites ni N-ethyl and methylamine kaysa kay N-propanamine. Kaya, ganun na nangyayari. Okay? So, the next interaction is ion-dipole interaction. So, ion-dipole interaction is an interaction between a dipole, okay, a dipolar compound, a polar compound, and an ion. Okay? So, that's effective interaction kung mataas ang polarity ng polar compound or yung solvent. These are the solvent molecules, yung water, okay? And solute molecules, si NaCl. Okay? So, effective ang interaction yan kung mataas ang polarity ni solvent at yung ion mo ay soluble and hindi siya masyadong malakas ang interaction niya dun sa salt. Okay? So, let's talk about solvents. So, water has 4 H-bonding sites. So, effective siyang solvents. Small molecule. Okay? Ethanol, 3 lang ang H-bonding sites niya. Pero, tapos meron pa siyang non-polar groups. Again, we consider this a non-polar group. Kasi CH bonds lang siya. Or ano siya, hydrocarbon groups lang siya. Acetone, okay, wala siyang H-bond donor. And it has non-polar groups. Okay? Puro siya acceptor. Hindi siya nag-hydrogen bond in itself. Okay? So, we can classify these 3, actually. So, for water, tingnan nyo, ito ay solubility ng NaCl sa iba't ibang solvent. So, very soluble siya sa water kasi very effective na solvent ang water. Okay? Tingnan nyo, kasi meron siyang 4 na H-bonding sites. However, si methanol, okay, mas mababa yung boiling point or I mean solubility. Okay? Tapos, ayan. Okay, so, isa lang ang kanyang H-bonding, actually dalawa ang kanyang H-bonding acceptor, isa lang ang donor. Si water naman, dalawa ang acceptor, dalawa din ang donor. Si ethanol, mas marami siyang non-polar groups kumpara kay methanol, kaya mas mababa yung solubility ng NaCl sa kanya. Propanol, mas marami siyang non-polar groups, so mas mababa. 2-propanol, 2-propanol is branched, so mas mababa yung surface area niya kaysa dun sa N-propanol. So mas mababa din ang solubility. Acetone does not exhibit H bonding, so siya yung pinakamababa. Okay? So these are the observations. Solubility decreases as the number of H donors decrease, as the number of non-polar groups increase, and as it becomes more branched. Tsaka kapag ka nawawala yung hydrogen bonding capability nung iyong solvent in the pure state. Okay? So definition of terms. Solution is a homogeneous mixture, okay, ng solute and solvent. So ang ibig sabihin ng homogeneous mixture, isa lang ang phase na makikita mo, isa lang ang nakikita mong entity kahit dalawa silang components. Okay? So if you mix sugar with water, isa lang ang makikita mo doon, yung water lang. That's one phase. Even though may sugar doon, hindi mo malalaman kung pure siya o meron siyang sugar kasi homogeneous yung mixture. Okay? Solute, that's the component of interest. Yun yung tinatanong mo kung ano yung concentration niya. So, for example, you have 0.01 molar, okay, sugar doon sa iyong mixture. The 0.01 molar describes the amount of that sugar. Okay, the amount of solute. Okay, solvent, it's usually the major component of the solvent. The solvent is the one that dissolves the solute, obviously. Okay, it's the one that determines the concentration. If you add more solvent, bumababa yung concentration no solute. Okay, so solvent-wise, we have three types of solvents. Polar protic solvents. So kapag polar protic, ibig sabihin meron siyang H-bond donor. So example nun, water. Okay? Polar aprotic solvents, siya yung compound or siya yung solvent na polar pero walang H-bond donor. Does not have an H-bond donor. So ang example nito ay acetone or formaldehyde. Basta meron siyang O, meron siyang N or F, pero wala siyang OH bond, wala rin siyang NH bond, wala rin siyang FH bond. Non-polar, this is obvious, so wala siyang net dipole moment. Okay? So, ion-dipole interaction is very sensitive to the solvent nature. Polar protic solvents stabilize both the cation and anion kasi malakas ang partially positive and partially negative ng iyong solvent. So, nasa-stabilize niya pareho yung solute, okay, yung solute cation tsaka yung solute anion. However, kapag hindi ka protic or wala kang OH, NH, or FH bond, hindi mo masyadong may stabilize si anion kasi wala ka ng hydrogen na partially positive. Ang meron kang partially positive, yung carbon, which is weakly positive. Okay? Ang mangyayari, yung anion mo, magiging unstable. So, kapag unstable ang anion mo, hahanap siya ng point of stability. Kakabit siya dun sa cation niya. So, hindi magkakaroon ng solubilization. Okay? Ito naman, may stabilize naman ng oxygen si cation but not the anion. So it still won't work, okay, entirely. So mababa ang magiging solubility mo. So consequences of IMFA, so surface tension, viscosity, vapor pressure, osmotic pressure, boiling point, and melting point. So surface tension increases with increasing IMFA kasi surface tension is the force exerted, okay, by the inner part of the liquid dun sa surface. So if you have a liquid, okay, if you have a liquid, Tapos ito yung surface, ito yung the rest. Surface tension is the actual force exerted by the inside of the liquid dun sa uh, surface. So, ang mangyayari dyan, parang napupull yung surface pababa. Okay? So, tumitigas ang yung surface. So, nagkakaroon ng stiffening yung surface mo. That only happens if you have high IMFA. Kaya ang water, mataas ang surface tension mo. Okay? Viscosity, resistance to flow. This is obvious kapag mataas ang interaction between particles. Mataas ang viscosity. Vapor pressure increases kapag lower ang IMFA. Kasi nga, mas maraming nag-escape na gas. So, na-discuss ko to last time. Kapag maraming nag-escape na gas, ibig sabihin hindi ganun kalakas yung interaction mo dun sa liquid or solid phase. So, mataas ang magiging yung vapor pressure due to the low IMFA. Osmotic pressure increases with increasing IMFA. Since, yun nga, ang osmotic pressure naman, okay, if you have a semi-permeable membrane, if you have the liquid here, okay, and you have the liquid plus solute, yung force na in-exert ng liquid dun sa semi-permeable membrane para makapasok siya sa kabila, yun yung osmotic pressure. Kung mataas ang interaction ng solute sa liquid, okay, kung mataas ang IMFA, so ibig sabihin mas gugustuhin ng liquid na mapunta sa kabila para ma-balance yung concentration. So the IMFA, the osmotic pressure increases. Okay? Boiling point is the amount of heat or the temperature at which your liquid changes to a gas. So kapag mas mataas ang enthalpy of vaporization or yung energy needed to vaporize your liquid, the boiling point is technically required at a higher temperature or mas mataas ang boiling temperature ng iyong solvent. Okay? Mataas kasi ang IMFA, no? Ibig sabihin. Freezing and melting point is analogous to the boiling point. Pag mataas ang IMFA, the solid phase, mahirap siyang i-melt.